Hi everyone, it's Miss Nergz again. Welcome back to science class. Hope you guys all are doing really great with this quarantine stuff. And I hope to fill all of you with information. So keep up with this video. Today's lesson is about forces. Unit 6, Chapter 2, Lesson 2, which is page 266. Alright, force. What is a force? Force is a push or pull. It transfers an energy. Force is a transfer of energy. You have an energy and you give your energy to something else in order to move it. Speaking of giving forces or giving energy, for example, if you kick a ball, you are forcing it to move. You force this non-living ball to move, so you give it energy, and it moves the way that you gave it force. You gave it energy. All right, and your friend is in front of you, and he catches it. He catches the ball, so he stops the ball from moving. What does that mean? He stops the energy that you gave to the ball. All right. What if there were no one to catch the ball and it rolls and rolls and rolls till it stops by itself? Well, there's no monster or ghost to catch it. It's friction force. In this case, the ball will stop by itself. Because of what? Because of the friction force. What is friction, you might be asking? Friction force is the force that keeps objects that are touching each other from sliding past each other. Now all of you guys do this. Rub both of your palms, both of your hands into each other. What do you hear? You hear some scratching, right? You hear your hands like they're scratching. It's friction. You are making this friction force. They are slipping and sliding past each other. It's the same for the ball. The surface of the ball is touching the ground, and the ground is rough. It's not smooth. All right? So that friction makes it stop. So in this case, we learned that there has to be a force to stopping something moving. Otherwise, everything will be moving infinitely. Friction force is between the surface of two objects sliding past each other. Now look at this man. This man tries to push this weird drop. So the motion is to the right, and he is pushing or forcing this counter, this weird drop, to the right direction. But the force of friction is always against the movement. Friction force is always against the motion or the movement. Why? If there were no friction, so it would have been very easy for this man to move this weird drop. Guys, please look at this picture. You see two men, they're playing ice skating. I'm pretty sure that you went to ice skating and you know how slippery is it. Why? Why is it slippery? Why the ground that you put your feet on right now, in your house, in your garden, why is it not so slippery? Because the friction of those ice skating players' shoes, even though they have special shoes for that, they're very smooth, okay? The friction between the shoes and the ice is very little, very small. That's why they can slip and slide on the ice. That's why you can't do this game like in your house, in your room. You need a very slippery surface to get reduced of this friction force. Changing motion. Alright, we have two types of changing in motion. Either it's a change in speed or change in direction, or both. Those changes are named acceleration. You might be familiar with this word, acceleration. Maybe you have heard about this in a storybook or something somewhere else, that it says, for example, the car accelerates up or the car accelerates down. What does that up and down mean? Well, acceleration is any change in the speed or the direction of an object's motion. If you look at this picture, uh, acceleration is a change in velocity. Velocity is speed, okay? Speed or direction. Let's pretend you are with your father. Your father is driving the car. All right. He speeds up, so he is accelerating up, okay? Or he might decrease the speed of the car to stop or to park the car. So this is accelerating down. Or if he's changing direction, you're going to school and suddenly you realize that you have forgot something. You forgot your science book, for example. You go back. So this is also accelerating down because you have changed the direction. So put this in your mind. Acceleration is a change in speed or direction. Change in speed or direction is called acceleration. Adding forces. I need you to read this with me. When you call your friends to help you to move a heavy box, you're actually asking them to add some forces to be equal to the weight of the heavy box. So you guys can move it very easily. There will be acceleration. What does that mean? For example, we all are strong, but you might not be so strong that you lift a couch, okay? Lifting a very heavy box. So you're asking for some help. Please, can you help me lift this box? So you both, if you add up both of your strength, both of your forces, so your force will be equal to the heaviness of this box. So you can lift it. This is adding forces. Or try playing rope pulling with your friends. Whenever you go back to school, try this. Or you can do it with your siblings at home. The stronger one will win, right? Why is that? Why the stronger one will win? Why not the weaker one? Because if you add both of your strength, which means both of your forces, the greater part will go to his part, to the stronger one. So the rope will move towards him. There will be acceleration. You have accelerated the rope or the stronger one. What if you both have the same strength? Well, the rope will not move. There will not be any acceleration. So in this case, in this point, you understand that acceleration is a change in speed, change in direction, right? You can realize it. Here's another example of adding forces. This is a very obvious example to make you understand what is adding forces. What does that mean? Well, this guy from left side has 25 Newton. Newton is a unit of force, which we're going to talk about in the next slides. And the other guy from right side has 20 Newton. Do you think one of them by themselves, only one of them, can lift this very heavy couch? No, they need help. So here is the adding up. 25 Newton plus 20 Newton equals 45 Newton. In this case, both of them, they can help each other to hold this couch. Measuring force. To measure force, you need to know two things. First of all, the unit of force, which is Newton, and the way to measuring it. Newton is the unit for measuring force. Just like how we have units for anything in physics, in science. For example, we have a unit for measuring mass, which is gram and kilogram. And we have unit for volume, which is milliliter for liquids. And how to measure the force. You have to measure the weight of an object. You might be wondering, teacher, what is weight? Isn't it the same as mass? I actually, when I use the electronic balance, I'm measuring my weight. Well, let me tell you, this is wrong. This is very wrong. When you're using the electronic balance, you are measuring your mass, not your weight. Because weight depends on gravity, but mass does not depend on gravity. We're going to talk about this interesting topic. Let me introduce you to weight. Weight is a measure of the force of gravity between Earth and the object. Some of you might be wondering or thinking about when I'm talking about Earth and object and stuff, you might be thinking about moon and the other things as well. See, this student says, so we have to travel to the moon to know an object's weight. No, let me tell you, we can use spring scale. Spring scale is a tool that has numbers on it. Okay, just like how we have used the graduated cylinder, it has numbers on it and a spring. All right, so you hang on it, hang whatever you want to measure the weight of. You hang on it and it's telling you about the weight because weight depends on gravity. Alright, here's a very obvious example to tell you the difference or to differentiate between mass and weight. Weight changes due to our location. It depends on Earth's gravity, but mass never changes. Never changes. It does not depend on Earth's gravity. So, think about it. If you go on the top of a mountain, your weight will be different of your weight if you're standing by a lake. Alright? Look at this astronaut. The mass, 100 kilogram, 100 kilogram. On moon, on Earth, Mars, anywhere it does go. It's the same. The mass will never change, but the weight, the one which depends on the gravity. Of course, if you're going to moon, you'll be out of the gravitational force of Earth. So the weight will change. 980 Newton, and on moon will be 162.2 Newton. See how it does change? So never ever get complicated about mass and weight. Mass does not depend on Earth's gravity, but weight does. Okay, students, I really want you to do the chapter review, please, please. Hope you guys enjoyed Grade 4 Science because we have finished it, and I really am hoping from the bottom of my heart to make you satisfied with my way of teaching you. I love you guys very, very much, and I miss you so much. I miss you to the moon and back, and I hope to see you very soon. Thanks for listening.